Wouldn't it be awesome if we could time travel? Something like this. Or this. Or this. When you build background services, it's quite common to have that need. You have code that executes at a given frequency, so you need to test it, and it's quite hard to do it. If the code only executes every 5 minutes, you need to start playing around with things like waits and put your code at sleep while testing it. And that can lead to slow and flaky tests. The good news is that now we have an alternative. With .NET 8, we can be masters of time. We can control the flow of time. And that is quite useful for those scenarios. And I will show you that, but before, let's time travel once again, because it's starting to rain. Okay, so let me show you what I mean when I say that with .NET 8, we can time travel. But first, let me take off my jacket. Okay, I'm getting used to this. So, if we want to build a .NET service that will run in background doing something once in a while in a given frequency, likely you would go online and you would search for that. And likely you will land into this page. And here, if we scroll down just for a bit, we'll go into the first example where you can see how to build a timed background task. So this is extremely useful when building things like I need to check a given database every 10 minutes. I need to run a process once a day to execute a given calculation. I need to go to a database, look for new customers every hour to send them an email. And in the most recent versions of .NET, you can find this idea of the timed hosted service. So it's still a hosted service. However, we'll use a timer, as you can see here, to define the frequency when our method, this one, will be executed. Then we just need to define in our service registration that we want to add a new hosted service that is that timed hosted service. So let's do exactly that in a project. So I created an empty API using Rider, and in this API, the only thing that I've done was to create this timed hosted service. That is an exactly copy of everything that you can find on that page. Besides that, I have done the hosted service registration that is defined there. And an important note is that currently, this application is built with .NET 7. So in .NET 7, if I wanted to test, for example, that when this timed hosted service runs, and you can see here that there's an implementation that every single time that it executes, you can find here the timer. The timer will call the do work, and do work will increment a given variable. So what we know is that this implementation by the documentation, what it's doing is simply every single time that it runs, so every 5 seconds, it will increment a variable. What if I want to test this? What if this implementation was, instead of incrementing a variable, was doing something like going to a database to do something? In .NET 7, if I want to test that, I need to do the following. So I would create a new testing project. I usually use XUnit. And that testing project, I would create a test. That test needs to be asynchronous. Then I would define this hosted service, this worker that will keep working and will execute every 5 minutes an increment of a number. The hosted services have a method that is a start async. You need to run that start so it kicks off. And it's in this process that will start the cycle of the 5 seconds. However, this hosted service is configured in the following way. If we go back there and we look into our timer, you can see here 2 important definitions. This third argument here that says timespan.0, it's the time of the first execution. So basically, this is configured in the following way. It will execute right away the function do work, and then every 5 seconds, by the period defined here, it will run again. So this means that if I assert the count, that number that we are incrementing, right away I will have 1 after the start async. However, I want to be sure that this thing is respecting the recurrent pattern that I defined. So I want to be sure that after 5 seconds, it will execute and increment the counter. How can I do that? Before .NET 8, you will need to do something as this. You will basically wait for a given number of seconds or the time that you need so that action is performed until the moment that you can do the assertion. And the assertion in this case will be something as simple as this, just checking that that count is equal to 2. However, this could be something like checking if a given repository was invoked, if we got a given message. You know the use cases. So what is important to define here? This simple task delay that we have here is causing my test to take at least 6 seconds to run. So I'm making my test slow by the fact that I need to wait for the normal time flow, the continuity of time to happen. If I have a period of 10 minutes, now I need to wait 10 minutes to test this thing. So what usually we do as a workaround is that we'll try to inject those definitions, those seconds, and work with that. But even then, sometimes you land into different problems, like the tests become really flaky because you are trying to adjust the optimum speed of the delay to the time that it executes. So this is not the best way to do this type of test. So even having a way to work around this by injecting through a configuration the number of seconds, we still have flaky tests sometimes. So it's an hard problem to solve to have these tests running fast and being stable. The good news is that with .NET 8, we have a new feature. .NET 8 has introduced the concept of time providers. And time providers let you control the flow of time. It's like if I could speed up the clock. If I could jump right away to 2 or 3 hours after. It's like if I could time travel. And that makes these type of tests extremely easy. Let me show you. The first thing that we need to do is to upgrade our projects to .NET 8. Quickly change my CS proj on both cases to .NET 8. And if I run my tests, they still go green. However, they take a long time to run. And we want to get rid of those 5 seconds or 6 seconds in this case and make this test go faster. And since now we are in .NET 8, how can we do that? So let's go into our time-hosted service. And now let's take advantage of the new concept of the time provider. So it will be quite simple. In the constructor of your hosted service, you will do something like this. You will define a time provider argument, create a field for it, and now we go into our start async, and there we will change this timer. So instead of creating a new timer, we'll use the time provider to create the timer. In timeprovider.createTimer, and now he's complaining because the new interface, instead of returning the type timer, it returns an interface of iTimer. So let me change the definition here of my field, and that will cause another error. So with this change, the timer.change that we usually call with the timeout infinite or the period 0 to cancel everything, we need to do it in a different way. Now it can be as simple as defining the timeout with the infinite time span. So with these simple changes, now everything stays the same. The way that it is being executed, it will take the 5 seconds to run. And since my test is complaining because now I have a new argument and I don't have it there, and I go there and I define that the time provider is equal to timeprovider.system, it will basically stay working in the same way. If we run the test, it will still take those 6 seconds to run and to see the green state. And now let's create a new test side by side to see how we can take advantage of this feature. So I will copy the test and I will name it test time travel. So what we'll do here, first we can install a NuGet package that is now available. That is the Microsoft extensions.timeprovider.test. While I'm recording, it's still in a pre-release. However, in the following days, it will come out with a new version of .NET 8. So if I add this package, now instead of defining here the timeprovider.system, I will create my own time provider. So this fake time. And I will provide it to the time-hosted service. Now I can do something as simple as this. Instead of awaiting the task delay, now I can go to my fake time and say, please advance 6 seconds. What does that mean? I'm shifting the time forward. It's like if the internals of .NET would work with a kind of an analog clock, and now I'm shifting the hour. So I moved forward 6 seconds. Now let's see what happens when we run this test. Extremely fast when compared with the other one. And let me run it again and show you with the seconds of both executions. Now you can see here that I'm not fooling you. One is taking 6 seconds and 4 milliseconds, and the other one 39 milliseconds. Now imagine that you have a lot of those tests running in your system. It takes a long time to run. Now imagine that instead of 6 seconds, it's 10 minutes, it's 15 minutes. So this is an exciting feature to adopt once you move to .NET 8. It will simplify your tests, but also it's an opportunity to remove the flakiness of all those tests where you have been doing a task .08, for example. However, let me point out that this is not the only problem, the only testing problem that with .NET 8 you will be able to solve. In this video right here, I show you how to use TimeProviders to address another common issue, especially around unit testing, that was quite common in .NET, and with .NET 8 we finally have a way to avoid it.